Welcome. Today we'll be doing a lesson on horizontal and vertical asymptotes, along with open circles within them. Before getting into the video, there's some basic prior knowledge you want to make sure that you have down so that you will be successful throughout the lesson. A few vital skills that you want to have is the ability to factor, problem solve, and you want to have a basic understanding of vocabulary, words such as numerator and denominator. And if you succeed in those concepts, then you should have no issues throughout the lesson.
Now we're going to do horizontal asymptotes. The line y equals b is a horizontal asymptote of the function y equals f of x, only if y approaches b as x approaches infinity. So what does this mean? As the graph approaches infinity, there is a value on the x-axis that corresponds to b that will make the function undefined, resulting in a horizontal asymptote.
When looking for horizontal asymptotes, there's three ways of approaching it, alright? So you want to make sure that you're using the right method, that way that you don't come out with the wrong answer. So the first method is when the degree of the numerator is equal to the degree of the denominator. An example of this is here, when we have x squared minus 9 and x squared minus 2x minus 15. As you can see, we have x squared and x squared, which is the same degree. The second example of this is when the degree of the denominator is greater than the degree of the numerator. One example of this is here, when we have x over x squared minus 9. The difference here is where there's a 1 to the power of 1 and then to the second power. The third and final example is when the degree of the numerator is greater than the degree of the denominator, and there will be a slant asymptote, not a horizontal asymptote. So if you want to find information on that, you're going to have to watch Kufi and Sam's video of when the highest degree of the numerator is smaller than that of the denominator. And when that happens, y will equal 0. Alright? So we're going to go through an example where we have 5 over 3x plus 2. Okay? So in this problem, considering that the numerator has a lower degree than that of the denominator, y will equal 0. So now we're going to see what this looks like when we graph it, okay? So we're going to graph this a little different than we do regular, so let's see how we do. So you want to draw your graph. Okay. Now, because y equals 0, okay, we're going to put a little couple points on here. Considering that y equals 0, we're going to have a horizontal asymptote at 0. Another scenario of solving for the horizontal asymptote is when the highest degree of the numerator and the denominator are equal. You want to divide the coefficients of the leading terms to get the horizontal asymptote. Examples to see what I mean visually. Okay, so here we have an example where we have 4x plus 3 over x plus 1. Considering that the denominator is the same as the numerator, we're going to divide these two coefficients. So 4 divided by 1 will equal 4. So our horizontal asymptote on our graph will be at 4. Okay? Now the second example, we have 5x squared plus 7 over 25x squared plus 2. Now, again, we have the same degree, so we're going to divide 5 divided by 25, which will be 1/5. Now we're going to see what these look like on the graphs. Alright, so now we're going to graph our first example of 4x plus 3 over x plus 1. So we're going to go up on the y-axis, and we're going to have a horizontal asymptote at 4. So let's put that in. 1, 2, 3, 4. We're going to draw our asymptote.
The line y equals a is the vertical asymptote of the function y equals f of x if y approaches positive or negative infinity, as x approaches a from the right or left. This graph would have a vertical asymptote at x equals a. When you're finding the vertical asymptote, you set the denominator equal to 0 and find all the values that make the denominator undefined. resulting in an asymptote at those points. Now let's try an example. We have f of x equals 3 over x minus 2. So we're going to set the denominator, x minus 2 equal to 0. X minus 2 equals 0. Then we're going to solve to see what makes x equal to 0. So we're going to add 2 on both sides and get x equals 2. And that's going to be cases where you have to factor to break down polynomials. Here we have f of x equals x over x squared minus x minus 2. So in the denominator, we want to know what multiplies to equal negative 2 and adds to equal negative 1. So it's going to break down to x minus 2 and x plus 1 over x. Now from here, you want to set each factor equal to 0 so you'll know where the vertical asymptote is. So x minus 2 equals 0 and x plus 1 equal to 0. Now you want to solve each one. So you'll add 2 on both sides here. And you'll have x equals 2. And from here you want to subtract 1 from both sides. You have x equals negative 1. And these two will be your vertical asymptotes. Now we're going to do open circles. And this is extremely important when doing rational functions. An open circle generally occurs when there are factors that are common in both the numerator and the denominator. Now let's try an example. Here we have x plus 2 and x squared over x squared minus 4. So this can be factored down to x plus 2 and x minus 2. Because this is a difference of squares problem. So when you look at the numerator and denominator, you see that there's an x plus 2 that is common in both the numerator and denominator. So these two would cancel out, and there would be an open circle. And whatever value makes x plus 2 equals 0, which would be negative 2. When finding the asymptotes, usually the domain helps predict it. But if a factor cancels out during simplification, you will have an open circle and not an asymptote at that value. And it's important to remember that there can also be a vertical asymptote depending on how the polynomial factors down. Here is our last problem. In the numerator, we have x squared plus x minus 6. And in the denominator, we have negative 4x squared minus 16x minus 12. So when you want to find what multiplies to negative 6 and adds to 1. So in the numerator, we have x plus 3 and x minus 2. Now if you look in the denominator, you'll see that there is a common factor throughout the whole term. Now when you find it out, it is negative 4. So you'll take negative 4 out from each one. You'll have x squared plus 4x plus 3. Now from here, you want to break this down into simpler terms to see if it has a common factor with the numerator. So negative 4 on the outside, and you have x plus 3 and x plus 1. Now when you look in the numerator and denominator, you'll notice that there's x plus 3 in both of them. So these two would cancel out, and there will be an open circle at that point. So you want to set x plus 3 equal to 0 and solve. So subtract 3 on both sides, and you'll have x equals negative 3.